Probabilistic modeling to determine the correlation between time and car accident mortality rates.
For this table of contents, this will allow you to reference who will be speaking about what topic and just an overall summary of everything we were trying to get across in this project.
At our project, we have decided to focus on the correlation between teenage deaths by quantity with respect to their age and gender. We achieve this by referencing charts, graphs, data points, probabilistic modeling, and other tools to ultimately show a relationship between these three variables.
To start this experiment, we needed to collect data of overall deaths in the United States per 100,000 people, ranging from the year 1975 to 2015. We then proceed to specifically look into the most recently available year and conducted our test accordingly. With the data set from 2015, we utilized probabilistic modeling to predict future mortality rates in the United States. The graph that you're seeing right now on your screen is a graph broken down by age group. So we have 16 to 19-year-olds, 20 to 34, 35 to 69 years old, and then 70 plus.
From the data acquired through research, we were able to plot certain pieces of the data in order to visualize the correlation between teenage deaths over the span of months, days, and even specific hours of the day. From this data set, we can see that deaths increase around May to September. This can be potentially explained by the fact that summer vacation for most students is around that time, and that could also lead to an increase in these numbers. Now, referencing the second data set, as most would expect, the main number of deaths from teenagers mostly come during the weekend. Friday, not too bad, but Saturday and Sunday specifically have a tremendous increase in these deaths. Lastly, this third data set took me by surprise, if I'm completely honest, because I would assume that from 6 p.m. all the way to maybe 3 a.m., I thought that's when it would be the highest. However, the data set doesn't seem too skewed. It does seem that for the most part, it's relatively equally distributed.
Data from student experiments / surveys. With this data set, we were able to determine the linear regression for accident rates amongst males and females. Upon further inspection, one can then make an assumption as to what the numbers may look like as the years follow. We used this graph to shape our predictions and formed a trend line within those plotted points on the graph that you guys can see to make our probabilistic modeling. So we're actually going to use males and females to do our probabilistic modeling, which you will see in the slides that are about to show up.
The reasoning as to why we focus on teenagers specifically with this data set is due to the fact that although the population of 13 and 19-year-olds is around 12% of the population compared to the highest being 35 to 69 years old, the 13 to 19-year-old was around 16 million, while the 35 to 69-year-old was around 140 million. The number of accidents actually between 13 to 19-year-olds is around 27% of what the amount is for 35 to 69-year-olds, thus implying that teenagers are the most susceptible in this situation.
All right, probabilistic modeling. So for probabilistic modeling, like I said, we use males and females. We plotted out the points from the year 1975 to 2015. And these account for mortality rates. So for males, we took the trend line, we made an equation, and as you can see on the right side on the legend, you can see the equation for each one. And yeah, we're using this graph to predict the deaths in the years 2016, 2017, 2018, and 2019. And the reason why we did 2016 and 2017, although it's not future, it's not future from us right now, was because our data got cut off in 2015. So we just did it from 2016 all the way to 2019. All right, so on to the male. We actually did two sides of the probabilistic modeling. We did one for males and one for females. So we took the original graph that you guys can see on the left-hand side, and we condensed it and made it more accurate. We did the trend line, and what we got for 2016 was 1,908 deaths. And then proceeding to 2017, we got 1,784, then 1,660 for 2018, and finally, our out of 600 cases for 2019, we got 1,536 deaths. So as you can see, it's a linear regression. The deaths are going down, and as you will see right now for the females, the male one actually goes down much quicker. but that's to put in account that there's actually more male drivers than female drivers. For the females ranging from ages 13 to 19, we got, for 2016, we got 1,220 deaths. 2017, we got 1,184. 2018, we got 1,149. And 2019, we got 1,114. So as you can see, it's barely anything. It's like about more or less 40 deaths that are getting minimized per year. But there isn't as many female drivers as there is male drivers. Yep.
To conclude, we have noticed a trend over the last 40 plus years that male accident rates have begun to notably decline. Female accident rates are declining also, however, not nearly as fast. More importantly, the overall ratio of male to female deaths in these accidents has changed minutely. Thus, taking into account the fact that even though the population changes on a yearly basis, we can still observe these changes. So throughout the whole years of 1975 to 2015, and even into specifically 2015 data, there was very minimal population change for teenagers aged from 13 to 19, which is why we believe that this specific age group was the best to study, since there wasn't that much fluctuation and the numbers over time haven't varied as much. For example, 35 to 69 years old were, I think, around 80 million or such in 1975, and then have increased exponentially to like 140 million. So those numbers of deaths might be a little skewed. All in all, we use probabilistic modeling, linear regression, statistical analysis, and some other factors that were taught in class to be able to complete this project. We hope you enjoy it.